Hello everyone, welcome to video number 6 of AP Computer Science A. Before we get into the main topic for today, which is recursion, first we're going to learn about two string operations, substring and indexOf. So substring, string.substring int A, int B, so that will return the substring of the string from index A to index B, including the character at index A, but not including the character at index B. If this is confusing, then just wait until I show the examples. And you can also just take one int as a parameter, and that will return the substring of the string from index A to the end. Here are some examples. abcdefgh.substring2, that's this C right over here, comma 5, which is this F right over here, would return CDE, because remember that you want to include this C right over here, but you want to exclude this F right over here. And then 6jivr.substring 0, comma 4, 0 is this 6 right over here, and 4 is this R right over here. That will return 6jiv because you're including the 6 and you're excluding this R. efhan.substring 3, which is this 8 right over here, would return 8n because you want to go from this 8 to the end. And then 3jd7h.substring 0, 0 is this 3 right over here, would return 3jd7h because you're starting from this 3 and you're going all the way to the end. So that's substring, and now indexOf. So string.indexOf char A returns the index of the first appearance of A inside of the string. If A doesn't appear anywhere inside the string, -1 is returned. So here are some examples. aibnr8.indexOf v would return 2 because the first appearance of v inside this string is at index 2. udndkr.indexOf d would return 1 because that's the index of the first appearance of d. ruxn7a.indexOf e would return -1 because e doesn't appear anywhere inside the string. You can also take a string A as the parameter for indexOf. And what that will do is it will return the index of the first character of the first appearance of A inside of the string. If A doesn't appear anywhere inside the string, -1 is returned. So here are some examples. od8 for mj.indexOf d8 would return 1 because this is the first appearance of d8 inside of the string, and the index of the first character, which is D, is 1. 8hwj8h.indexOf 8h would return 0 because this is the first appearance of 8h inside of the string, and the index of the first character, which is 8, is 0. fnjwl3.indexOf fnl would return -1 because fnl does not appear anywhere inside of this string. So now we're getting into recursion. So what recursion basically is having a method repeat itself. So right here we have a method called f, and you can tell that it's a recursive method because it calls itself inside of its own code. So right here in the main method we have print f of 30. What will that print out? The best way to solve this is to work through it step by step. So let's do that together. All right, so first we have f of 30, and 30 is not less than 6, so we don't return 5. Instead, we return a, which is 30, so 30, and then plus f of a minus 8. So 30 minus 8 is 22. And then now we have f of 22. 22 is not less than 6, so therefore it turns into a, which is 22, plus f of a minus 8, and that's 14. 14 is still not less than 6, so f of 14 turns into 14 plus f of 6. And 6 is not less than 6, so this turns into 6 plus f of -2. And -2 is less than 6. So therefore, f of -2 just turned into 5. And then now, if you add all of these up, you're going to get 77. So therefore, this code should print out 77. And indeed, it does. So therefore, we solved it correctly. So I'm going to show you another example of a recursive method, but before we do that, it's important to know that whenever a block of code calls a method, that block of code pauses until the method is finished before continuing. So what that means here is we start with the main method. So the main method calls 1. So therefore, the main method pauses until method 1 is completed before continuing. And then 1, it calls 2. So 1 pauses until 2 is finished. And then 2, that will just print out 2. And then method 2, and then 2 is finished. All right, so now 1 can continue. So it prints out 1. And then after that, 1 is finished. So therefore, the main method can continue, and it prints out done. So overall, this code should print out 2, 1, and then done. So let's run this. And indeed, it does. So it is very important to know the order in which things are printed when you're dealing with recursion. So now I can show you the example of the recursive method. So I'm going to call the method mystery and make it a void method. And then the parameter will just be an int a. So what this method is going to do is first it's going to print out a, and then if a is less than 3, then we call mystery a plus 1. And then after that, we print out a once again. All right, and then in the main method, let's just call mystery and pass 1 as the parameter. All right, so what this code will do is first we call mystery of 1. So it will print out a, which is 1. So I'm going to put a comment here to keep track of what's printed. So first we print out 1. And then if a is less than 3, that's true. We call mystery a plus 1. So we call mystery of 2, and mystery of a, mystery of 1 pauses until mystery of 2 is complete. And what mystery of 2 does is it first prints out a, which is 2. So I'll add a 2 here. And then if a is less than 3, that's true. Then it calls mystery a plus 1. So it calls mystery of 3. And mystery of 2 pauses until mystery of 3 is complete. And mystery of 3, it prints out a, which is 3. And if a is less than 3, that's no longer true. So we get to this line right over here. So it prints out a once again. So once again, it prints out a 3. And now mystery of 3 is complete. So mystery of 2 can continue from here. So it gets to this line right over here. So it prints out 2 once again. And now mystery of 2 is complete. So mystery of 1 can continue. So it gets to this line right over here, and it prints out 1. So this code should print out 1, 2, 3, 3, 2, 1. And it does. So there isn't a lot to know about recursion. All that you really need to know is the process, where you go step by step and notice patterns. And that's pretty much it. Recursion is mainly about problem solving, and that's what the rest of this video is going to be about. In the description, under practice, you'll see some links, and right now I'll suggest clicking on the link that says MCQ, and that will take you to a Google Slides with 3 multiple choice questions that are representative of the types of questions that you'll see on the AP test. And I'll suggest that you give these a try, and don't worry if you can't solve them, because we're going to continue practicing multiple choice questions in the future. And keep in mind that you should not be using Replit.com to help, because you cannot use that on the AP test. But anyways, if you want to give these a try, then pause the video here and keep watching. I will solve problem number 1 in 3, 2, 1. All right, so it's problem number 1. You have a recursive function, and you start with f of 8. And let's go step by step. So 8 is not less than or equal to 5. So therefore we return f of a minus 2. That's f of 6 times f of a minus 1, which is f of 7. And 6 and 7 are both not less than or equal to 5. So 6 becomes f of 4 times f of 5. And 7 becomes f of 5 times f of 6. And 4 and 5 are both less than or equal to 5. So therefore, f of 4 and f of 5 all turn into 2s. And then f of 6 turns into f of 4 times f of 5. And then continuing, so both f of 4 and f of 5 turn into 2s. And then multiplying all of these together, you'll get 32. So therefore, the answer is E. And now moving on to problem number 2. So this problem is basically asking, what change do we need to make to mystery 2 in order for mystery 1 and mystery 2 to always return the same thing as long as they are called with the same positive integer parameter n? So I'm going to delete this in order to make some space. So let's try a few examples. So let's suppose that we try mystery 1 of 1. That would return 1 because 1 is not greater than 1, so therefore we just return 1. And then mystery 1 of 2. So 2 is greater than 1, so we return 5 plus mystery 1 of n minus 1. And 2 minus 1 is 1. And we already know that mystery 1 of 1 is 1. So overall mystery 1 of 2 is 6. And then mystery 1 of 3, that is equal to 5 plus mystery 1 of 2. And we know that mystery 1 of 2 is 6, so overall mystery 1 of 3 is 11. And you might start to notice a pattern here. You see that each time you increase n by 1, the result increases by 5. So therefore, mystery 1 of n is equal to 5n minus 4. So what about mystery 2? Well, what is mystery 2 of 1? Well, in that case, we have total equals 0, and then x equals 1, while x is less than n, so while 1 is less than 1, and that's false. So we don't even run this while loop once, so we just return the total, which is 0. So this is 0. And then mystery 2 of 2. So we have total equals 0, x equals 1, and while 1 is less than 2. So that's true, so we run this, total plus equals 5, so now the total is 5, x plus plus, so x changes to 2, and then we have while 2 is less than 2, that's false, so we stop the while loop, and then we return total, which is 5. And now mystery 2 of 3. So it's similar. The only difference is that you run the while loop 2 times instead of 1. So that is equal to 10. And you might start to notice a pattern here as well. Basically, mystery 2 of n is equal to 5n minus 5. So the problem is that whenever you call mystery 2 of n, the result will always be 1 less than if you call mystery 1 of n. And in mystery 2, we return the total, and the total starts off as 0. So to solve the problem, we can just initialize the total as 1. And that answer choice was A. So therefore, A is the answer to problem 2. Problem 3 is asking what is printed out. So let's work through this step by step and see if we can notice a pattern. So we start off with f of an apple, and we basically need to consider the first character, which is currently capital A. So this Boolean's asking, is it a capital letter? And that's true. So we turn it to a lowercase letter. So lowercase a plus f of, if you remember what a dot substring 1 does, it basically removes the first character. So we're left with f of an apple, except without the first a. And now let's continue. So now the first letter is lowercase n. So this Boolean is false. And this Boolean's asking, is it a lowercase letter? That's true. So we turn it to an uppercase letter and then plus f of a dot substring 1. So we have lowercase a plus uppercase n plus f of space and then apple. And now let's continue. So now the first character is a space, so both of these Booleans are false, so we just return f of a dot substring 1. So that is just apple. And you might start to notice a pattern here. Basically, every lowercase letter is turned to an uppercase letter, every uppercase letter is turned into a lowercase letter, and anything that's not a letter is removed. So in the end, you're going to have an apple where the two A's are lowercase and everything else is uppercase. And that was answer choice E. So E is the answer to problem number 3. So now I would suggest clicking on the link labeled Creating Programs in the description, and that will lead you to a Google Slides presentation with 2 problems. So if you want, pause the video here and check it out. I will solve problem number 1 in 3, 2, 1. So the critical thing for the factorial problem was to realize a pattern, and that pattern is that n factorial is equal to n times n minus 1 factorial. For example, 6 factorial is equal to 6 times 5 factorial. So with that, you can create a recursive function to solve. So let's take an int n as a parameter, and if n is equal to 0, then we just return 1. And otherwise, we return n times factorial of n minus 1. And now let's call this method. I'm going to calculate factorial 6. It prints out 720, which is the correct answer. So now onto the Fibonacci problem. So if n is 1 or 2, so basically if n is less than 3, then we just return 1, and otherwise we return Fibonacci of n minus 2 plus Fibonacci of n minus 1. So that's the sum of the 2 previous terms. And now let's call it. I'm going to pass 6 as the parameter. It prints out 8, which is the correct answer. Today, you learned about substring, indexOf, and recursion. Try to remember these topics. It's not a lot to remember. You just need to remember what substring and indexOf do and how to solve recursion problems, which is going step by step and trying to notice patterns. In the next video, we will dig even deeper into recursion, and we will learn about how to determine the runtime of an algorithm. We will also learn about how to use recursion to make fast algorithms. I hope you enjoyed. I'll see you in video number 7.